And last but certainly not least is example 3, where we first factor out a monomial. So this is going to look at examples where before we start factoring to two binomials, we can first find a common factor between all three of these terms. So let's look and see if we can find what's the common factor between 20, 80, and 35. Now, I notice I just looked at the coefficients and the constant here because x squared x, there's no variable in common because our last term is a constant. However, in this case, the number 5 is a common factor for all three terms. So we're looking first for a common factor. In this case, it is 5. Remember, there's lots of ways to look for that greatest common factor, one of which is to do a factor tree. But we're looking for greatest common factor. So once we find what that is, we can say, well, first, I can factor out 5 from each of these terms. So if I was to factor out a 5, or in other words, 5 times what is 20x squared? Well, we're left with 4x squared. We do the similar thing for 80x. 5 times what is 80x? Well, 5 times 16x is 80x. And finally, 5 times what is 35? That is 7. In other words, when we factor something out, we're dividing that number out from each term. Now, we look at just this trinomial, 4x squared plus 16x plus 7. There's nothing that no factor that all three of these have in common, so we can now use our diamond and box method to factor this trinomial. This 5 is going to stick out in front. We are still multiplying by 5, so in our final answer, we need to keep that number. But for a while, we're just going to focus on this trinomial. So for the trinomial, 4x squared plus 16x plus 7, a times c, which goes in the top of the diamond, is 4 times 7, or 28. And in the bottom, b is this middle number, 16. These are all positive. I'm looking for two numbers whose product, who multiply to give me 28, and whose sum, or they add to give me 16. So 1 and 28, that's not going to do it. 2 and 14. 2 plus 14 is, in fact, 16. So I have my pair. Remember, this is like splitting up the second term here. So 16x becomes 2x and 14x. In my box, again, we notice I still have my finger covering this 5. It hasn't gone away, but we're just ignoring it for now. And so I just keep my finger right over that. I got a little pen on my finger, you can see there. So 4x squared goes in that first box. Again, we're still focusing on this trinomial. The 7 goes here in this second box. And then the 2x and 14x that I split up, or in other words, the 16x that I split up goes in the final remaining boxes. I look for common factors. So 4x squared and 14x have 2x in common. 2x and 7 just have a 1 in common. 4x squared and 2x, the first column, have 2x in common. And 7 and 14x have 7 in common. These are all positive, and so all of this is added together. And normally this would give us our answer, 2x plus 1 times 2x plus 7. That is the factored form of this trinomial. But wait, there's more. Don't forget that 5, we said would go on our final answer. So 4x squared plus 16x plus 7 factors into these two binomials. And then we also have this factor of 5 that goes right out in front. Try one example. You can take this second to pause and try quick check. 3, let's try one with a negative number. Let's try 3c. Pause the video and try that. I'm not going to work through the whole problem, but I will show you the first steps and then our final answer. Go ahead and pause. Okay, part C was 18k squared minus 12k minus 6. The first step, this added step of factoring out something first, we look for what do all three of these have in common. In this case, 18, 12, and 6 each have a 6 in common. When I divide by 6, I'm left with 3k squared. When I divide negative 12k divided by 6, I still have a negative 2k. And then again, negative 6 divided by 6, a negative 1 is left. We would do our diamond and box with just this trinomial 3k squared minus 2k minus 1. And our final answer, 6 times 3k plus 1 times k minus 1. All right, these are all of our videos for this section 9-6. There will be practice problems posted on Moodle, already up on RunWeb, and please feel free to come see me during office hours to go through more examples. Try Khan Academy and some examples there. There's some great examples in the book, but they don't use this method. So I would encourage you to use all of those resources that you have. Thanks, guys.